Hey guys, welcome to my channel. Let's learn graph theory today. Now what you see on your screen right now is a typical graph, although there are lots of different types of graph. You see some lines and some circles. Well, this is just so you know how to visualize a graph before we get into it, so you just get the gist of it beforehand. Now that you know how to visualize graphs, what are graphs actually? Now there are lots of other definitions for graphs, but I tend to go with any data structure or data set that tries to represent connectivity. Now let's bring back our graph for a second. In here you see these circles or datas that are connected via lines that are in the graph. Now these can represent any number of things, right? Let's say, for example, a friend group. So these are friendships between friends in a friend group. It can also be friends in a social media network. Another example could be of a transportation system. So a graph can also represent a transportation route and connections between different transport facilities. For example, the data points here are representing different transport stations or destinations, while the lines are just representing the connection or route between those destination systems, right? So I think you can already tell how useful and applicable graphs can be in real life. Now that we know a little more about graphs, let's learn about the different elements or terminologies of graphs. The first one being nodes. Now they're really easy to identify and are basically the heart of a graph. Nodes are these data points that make up a graph, as you can see. And they can either be connected or just can reside all by themselves. Now let's talk about edges. Edges are also fairly simple to understand. They are the elements in the graph that represent connections between nodes, as you can see. Let's discuss about degrees in a graph now. A degree of a node is the number of edges that are connected to a node. For example, 1 is connected to 2 edges pointing to 2 and 3, so it has a degree of 2. Alternatively, you can also say that a degree of a node is the number of nodes that it is connected to. Another important concept in a graph is weight. A weight is basically a value associated with an edge. For example, here the edge 1, 2 has a weight of 50, 1, 3 a weight of 40, and 2, 3 a weight of 30. Weights are important when we need to quantify and compare between different connections. Let's now discuss about graph components. So far we've seen graphs that have all of its nodes connected to each other, but that might not be the case every single time. In here you can see there are two different graphs, but they essentially belong to the same graph even though they're not connected. They're just called different graphical components of the same graph. Now let's briefly look at the different types of graphs. Now in this video we're just going to look at a couple of them, but there are lots of others, but we're going to be viewing them in other videos. So the first one we have is a directed graph. Throughout the video we've looked at graphs that had no arrows assigned to it on the edges. Directed graphs, however, has directions attributed to its edges. Think of it as a road that can only go in one direction specified to it. That is directed graph for you. Let's now discuss about cyclic and acyclic graphs. In the following graph, there is a cycle. So 1, 2, 3, and then 1, right? So if you wanted to start from the node 1 and then wanted to come back to itself, you can do that in this graph. So it has a cycle in it. And the graph with a cycle is called cyclic, and the graph without a cycle, you guessed it, is called acyclic. Now let's look into the ways of representing graphs. So we need a way to tell to a computer that this is a graph and these are the edges. So let's look at the ways we can do it. There are mainly two most popular ways to implement graphs. Let's look at the first one. Now this is an adjacency matrix. where the nodes are denoted by the rows and columns, and the edges are defined by the intersections between them. For example, if we wanted to represent a connection or edge between 1 and 4, we would simply mark these two cells as true. Now, although this looks like a convenient setup, it's not the most efficient, as it takes up a lot of space, which is not efficient at all for larger graphs. Now let's look at the adjacency list. Now this is a more popular way of representing graphs, and we will be using this way to represent in the future videos. In this way, we assign each node of the graph to a list that contains all the nodes that are associated or connected to it. For example, the node 2 is connected to 1, 4, and 3, and so on and so forth. In the upcoming videos, we will be coding these implementations and looking at them deeply in the compiler. Let's now try to wrap up the video by looking at some interesting graph concepts that we'll be covering in the future videos in the same series. Concepts like graph traversals like BFS and DFS, some pathfinding algorithms, we'll be covering minimum spanning tree, and we will also be finding the shortest path in a graph using different algorithms. We're also going to detect cycles in a graph and also going to cover connectivities in a graph. And that was it, guys. Thank you for watching the video. If you found it informational, definitely subscribe so you don't miss out on the latest videos that I'm going to be uploading on the series. Like and comment to let me know what you think, and most importantly, share this with your friends to help them learn something new and also to support me. Have a nice day and take care of yourself.